So, for this explainer, we're doing something a little different. We're not going to dissect some new, complicated research paper. Nope. We're going back to basics. We're going to look at the actual blueprint for how science itself works.
You know, it really all boils down to a pretty basic question. How do we actually know what we know? How do we go from just a simple what if to a real actual discovery? And believe it or not, we found our guide in, well, a pretty unexpected place. A high school chemistry lab manual published way back in 2002 in Istanbul. A simple guide, sure, but it holds a really powerful idea. And the preface, wow, it just captures the spirit of this so perfectly. It frames science not as some boring list of facts you have to memorize, but as this active, hands-on chance to really understand nature. Okay, let's dive in. So what this manual shows us is that scientific discovery, it isn't some kind of magic trick that only geniuses could figure out. Not at all. It's a process. It's a repeatable blueprint for asking questions in a structured, methodical way. At its very core, a scientific experiment is a lot like following a recipe. But, instead of baking a cake, you're literally cooking up knowledge. Every single step is designed to reveal one of the universe's little secrets. And this is what's so cool. The manual just breaks the whole thing down into 4 super simple logical steps. You start with a purpose. What's your goal? Then you follow a procedure, the steps. You write down your observations. What did you see? And finally, you draw conclusions. What did you learn? That's the whole game. And yeah, this whole 4-step process, it's got a name. You've definitely heard of it. The scientific method. And it is, without a doubt, the single most powerful engine for discovery humanity has ever come up with. It's been powering progress for centuries. All right, so we've got this blueprint. Now for the fun part. What kind of secrets can we actually unlock with it? What kinds of questions is this whole method built to answer? I mean, just look at the manual's table of contents. It's like a goldmine of pure curiosity. It asks things like, hey, can you take one single thing and break it into brand new things just by zapping it with electricity? Or how about this one? What happens if you just heat up some simple, everyday salts? Can they actually start to glow with colored light? And what could that even tell us? Then they flip the script. Instead of using electricity to change something, can you do the reverse? Can you just mix some chemicals together and poof, create an electrical current out of nowhere? And get this, it even gets into stuff we use all the time. Like, is it actually possible to make something like aspirin from scratch, right there on a lab bench with just some basic chemical building blocks? And boom, here's the answer to that first question, laid out perfectly. The manual shows that, yep, if you run electricity through plain old water, you can literally split it into 2 totally different things, hydrogen gas and oxygen gas. So what about that question with the salts and light? Turns out, yeah, absolutely. When you heat different metal salts, each one gives off its own unique, specific color. It's like a chemical fingerprint that lets you identify what you're looking at just by the color of the flame. Pretty cool, right? Okay, but here's the thing. These aren't just some dusty old classroom exercises from back in the day. Not at all. The principles behind these simple experiments are, quite literally, the foundation of our modern world. And this is the really crucial takeaway. Those simple high school experiments, they're the core science behind massive global industries. That experiment on separating liquids, that's how we refine crude oil into gasoline. Creating electricity from chemicals, that's the science inside every single battery you own. The scale is different, sure, but the fundamental science is exactly the same. So, when you really think about it, what this old manual reminds us is that a lab isn't just a physical room full of beakers and burners. It's something much, much bigger than that. It's a mindset. It's the idea that our natural human curiosity can be paired up with a practical toolkit. It's the framework that lets us stop just wondering about the world and start getting real, tangible answers. So that kind of leaves us with one last thought for you. This blueprint, this method, it's available to everyone. So if you had that toolkit and you could ask any question about how the world works, what would you want to find out?